Hi guys, welcome back to Business Statistics. We're going to get into section 3.2, counting techniques. As always, there's a companion worksheet that you should be using to follow along. You can download that from Brightspace from the Content tab for Module 3. So go ahead and use that. That's what worksheet I'm working with right now. Without any further ado, let's get into counting techniques. So I'm just going to go ahead and read off the definition here. I don't think I'm going to type it in. You guys can do that in your companion sheet. But the fundamental counting rule is defined as a counting technique that allows us to figure out the number of ways to complete a set of tasks. Okay, and this just then gives a variable to each task that you have, or it gives a constant to each task that you have, and essentially you're just multiplying all of the different options within each one of those tasks. Okay, so we'll just go ahead and do an example. This is a very simple concept, I think, that you guys should be able to understand relatively easy here. So the example says you have 8 shirts, 5 pairs of jeans, 12 pairs of socks, and 3 hats. How many different looks can you come up with? And the idea behind the fundamental counting rule, which I believe is on slide 24 if you are looking at the slides, or somewhere in the Learn Smart, Achieve that you're working on. But essentially what is going on is it is asking you to, let me get this pen working here. This pen always gives me fits, I don't know why, but okay. So just how many outfits can we come up with? Well, we have 8 shirts. Okay, so we can only wear 1 shirt at a time. We have 5 pairs of jeans. We can only wear 1 pair of jeans at a time. We have 12 pairs of socks. We're assuming we can only wear 1 of those at a time, and we have 3 hats. Okay, and then we just multiply all of those together, and we get 1,440. And that's that. 1,440 different, I guess we can say, options. Okay? So, without any further ado, now we're going to run our worksheets like this. I'm going to do an example, and then I'm going to give you a chance to try. So that's what this "you try" is for. Okay? So here we go. I'll go ahead and read through it, and then after reading through it, why don't you guys go ahead and pause the video and try your hand at it, and then we'll come back and see if you got the same answer that I did. So you try. You are getting married, and with your fiance. So this is what happens when you yourself write problems. This is what happens when I write problems. Is I write them in poor English, and then I have trouble reading them back. You are getting married, and with your fiance, taste testing foods for the meal at the reception. There are 7 different meats to choose from, 14 different side dishes, 3 different bread options, and 5 different desserts. How many possible meals are there? Okay. Go ahead, pause the video, and go ahead and try out this on your own with your printed version of the companion. Alright, so hopefully you had time to go ahead and do the example, but I'm just going to go ahead and do it as well. So, we have 7 different meats. My pen is driving me nuts right now. It keeps wanting to delete stuff. 14 different sides, 3 bread choices, and 5 desserts. And that's all kind of coincidentally going to shake out to be a similar number, but 1,470 options of meal. Okay? So that's the basic concept behind the fundamental. The next thing that we're going to learn about under counting techniques is the factorial operation. This is something that you probably have seen, well, you probably saw many, many moons ago, okay? And this is just essentially saying this is the product of a positive integer and all others below it. That's my definition. I believe the slide gives the definition of the factorial operation is a product of a given positive integer and all of the positive integers less than that given integer. Right? So it's just basically saying that integer times every other integer below it. Okay, not counting negative ones, and it's just an exclamation point. So our mathematical formula that we would see is going to look something like n with an exclamation point. Goodness gracious, this pen. Okay, so that's called n factorial. So the example that we have is 8 factorial. Okay. And that is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that just equals and when we multiply all of those out, we get 40,320. Okay, so that is our example for the factorial operation. I don't think that there needs to be a U practice. If you'd like to practice on your own, just go ahead and do 5 factorial or 3 factorial or whatever. It's pretty obvious what's going on here. So you just take whatever number it is and then just multiply it by every positive integer below it. Okay. So now we move on to combinations, which is a formula that's going to use the factorial function. Okay, a unique subset of size r drawn from a set of size n when the order of the chosen items does not matter and repetition of items is prohibited. Okay, so I think the best way to show that is just to do an example, which we will do now. It says the owner of the restaurant wants to offer some specials with the lunch menu at a popular restaurant. He wants to choose 4 items from a list of 6 to offer as specials every day. How many different combinations of specials can he offer with the lunch menu? Okay, and so if you had your PowerPoint slide following along, you would see that the formula here is something called n choose r. Okay, so it's n and r are subscripts there, and then the formula for that is just n factorial over r factorial times n minus r whole thing factorials. Okay, so n represents the size of the set. So in this case, n would be 6. Okay, and then r is the number that you're choosing. Okay, so then what we would do is then plug this in here. So we'd say 6 choose 4 is equal to 6 factorial over 4 factorial, 6 minus 4 factorial equals, and we can, this is going to go to 2 factorial, right? 6 minus 4 factorial. So then we would just have 6 times 5 times, okay, and then you'll see what I do here is I just say 4 factorial. Okay, 6 times 5 times 4 times 3 times 2 times 1, and that's what's really going on. But for the purposes of cancellation, I have this other factorial on the bottom here. And so I'm just going to go ahead and cancel 4 factorial and 4 factorial. So what we get is we get 30, which is 6 times 5, over 2. And that equals 15. Okay, so that was our example. Go ahead and you guys can get started on the U-try. I'll give you a couple seconds. Go ahead and pause the video, and then we'll come back and we'll work on it together. Okay. A small local brewery conducts tours of their facilities. The brewery produces 8 different beers, and every month a different random selection of 4 of those beers are made, available for tasting during the hours. How many different selections of 4 beers are possible from the set of 8 beers by the brewery? Okay, so our larger set that we're going to be choosing from is 8. Okay, and the amount that we're going to be choosing is 4. So we're just going to be doing 8, choose 4. Okay, so we have 8 factorial on the top, 4 factorial on the bottom, and 8 minus 4 factorial on the bottom as well. And so then we just go and do this, 8 times 7 times 6 times 5 times 4 factorial. Okay, we notice that this 8 minus 4, oh, did I write that wrong? I sure did. All right. So it's 8 minus 4, whole thing factorial. And then we get 4 factorial there, times 4 factorial. We can cancel one of those out. So then we get 8 times 7 times 6 times 5, all over 4 factorial, which is 4 times 3 times 2 times 1. And I won't bore you with the math, but it ends up being 70. Okay, so if you got 70, you did it right. All right, now we're going to move on to permutations. So permutations is very similar to combinations, except that it is when we don't care about order. Okay, sorry, it is when we do care about order. Combinations is when we don't care about order, okay? So the formula is slightly different. It's slightly less cumbersome. And so I'm going to go ahead and write the formula here as we do our first example, okay? So the definition is up there, and that says, is an arrangement of R items selected from a set of N items where order does matter. Okay, so here's a good example. A license plate begins with 3 letters. If the possible letters are A, B, C, D, and E, how many different permutations of these letters can be made if no letter is used more than once? And so you see why that's a permutation. So that's to say that ABC is not the same as CBA. Okay, but if we were talking about combinations, CBA would be the same as ABC. All right. So our formula is the set, or the amount that we're choosing, and P for permutation. Sorry, the amount that we're choosing from N, permutation, the amount that we're choosing, NPR. And that is just going to be N factorial over N minus R factorial. Okay, so in this case, how many are we choosing from? What is our N? We're choosing from 5 letters. How many are we choosing? We're choosing 3 letters. So then this is just going to be 5 factorial over 5 minus 3 factorial, or 5 factorial over 2 factorial, which is just going to equal 5 times 4 times 3 times 2 times 1 over 2 times 1. So we can get rid of those, and we just get 5 times 4 times 3, which is 60. Okay, so now it's your turn to try. So go ahead and pause the video and take a second to go ahead and do the you try. Okay, hopefully you got that in. Every year at the annual company picnic, there is a 3-legged race. The race involves 12 teams, and at the end of the race, gold, silver, and bronze medals are rewarded for first, second, and third place teams, respectively. How many different ways can these medals be awarded? And so then the thing that we notice is that, well, gold is different than silver, is different than bronze. And so like when people finish in different orders within that top 3, it actually is a different result. And so then that does lend itself to a permutation and not a combination, okay? So it's just something logical to think about there. And so now what are we doing? So we have 12 teams. So that is the set that we can choose from. So that's our n. Okay, 12. And the number of spots that we could finish is 3. So it's just going to be 12 permutation 3, which is going to be 12 factorial over 12 minus 3 factorial. Okay, I'm going to come down here to do this math. So 12 times 11 times 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. But I'm just going to call that 9 factorial, because if you notice at the bottom, 12 minus 3 is 9, and then that creates a 9 factorial on the bottom that we can cancel out, and then we get just 12 times 11 times 10, which is 1320. Okay, so that is the concept of permutations. You guys should study up on this. There should be a question on the exam. Certainly, it's on your homework on permutations, combinations, and the use of factorials and whatnot. But there will definitely be a question on the exam. Please, 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 guys, go ahead and ask me questions via email or in the discussion boards. Thanks so much, and on to the next section.